Hello everybody, how are you? My name is Mr. Mahmoud Hamid, chemistry teacher in Egyptian English school. We studied before the change of heat to combine to chemical change, okay? And study number one, the heat of combustion or burning reaction. In this session, we'll talk about the standard heat of formation. As a first, what is meant of formation? Formation. Each compound such as NaCl consists of two elements. Na element react with chlorine. Sodium react with chlorine. Okay? To form compound NaCl. This compound consists of primary element. Okay? When 1 mole of compound is formed, this compound is combined by change of heat. This change of heat called heat of formation. F, the first letter of formation. And this may be talk about heat, so it may be exothermic, or give amount of heat, endothermic. Okay, so the amount of heat released or absorbed during formation 1 mole of substance. This called what? This called standard heat of formation. Okay, so standard heat of formation, which is a quantity of release or absorbed heat when 1 mole of compound is formed from its constituent element, where this element are in their standard condition. Okay, for example, we have glucose. Glucose compound C6H12O6 consists of 6 carbon atom react with 6 mole of hydrogen compound and 3 mole of oxygen compound. When 1 mole of glucose is formed, is combined by change of heat of formation equal what? Equal negative 1260 kilojoule per mole. This 1 mole. So this heat called standard heat of formation. The standard heat is heat combined to formation of 1 mole only. Okay. This amount of heat of formation of glucose, and it is heat content of glucose. So why, Mister? Because the heat of formation of any element, it's supposed to be 0 in a standard condition. So the heat content of this element equal 0. The change of heat is the heat content of a product only, this compound. So change of heat delta H equal the heat content of a product minus the heat content of reactant. We will replace the heat content of a product by heat of formation of product and heat of formation of reactant. Okay. For example, in the booklet, page number 110, using standard heat of formation in calculation and change of heat content, okay, to this chemical reaction. For example, heat of formation of methane equal negative 74.6, and the heat of formation of methane equal negative 774.6. Carbon dioxide equal negative 393.5, and the water vapor equal negative 241.8 kilojoule per mole. So we want to measure the change of heat of this chemical equation. CH4 plus 2O2 producing CO2 plus H2O. But in this problem, we didn't find the heat of formation of O2. Why? Because O2 is element. The heat of formation of element equals 0. And this is given. Okay? We have the heat of formation of methane, carbon dioxide, and water vapor. So we can measure change of heat or delta H for this reaction. But the sum of heat of formation of product minus the sum of heat of formation of reactant. Heat of formation of product CO2 plus 2 mole of water, the heat content of CO2 plus 2 times this reactant, okay? 2 times 0 plus the heat content of carbon dioxide 2 times the heat content of water. Delta H for this reaction equals 802.5 kilojoule per mole. Okay? We have relation between heat of formation and stability of compound. Okay? What is mean of the stability? Stability just means if I have compound, for example, Na2CO3 or NaCl. If this compound is decomposed by heat to Na plus Cl, we can separate this primary element again. So it means unstable. This is called unstable compound. Unstable, this can separate from its primary element. But of this compound, we heat it and it is non-dissociated. So it's called stable compound. So, stable compound, it is a compound thermally stable at room temperature. While unstable compound, it is a compound that tend to dissociate it spontaneously to their primary element. Okay, we have a relation between heat of formation and delta HF of compound and its stability. For example, heat of formation of heat content, the compound which have negative heat content is more stable. This means what? This means the compound producing heat. If the compound producing heat, so it have negative sign. Delta H formation is negative. So this compound is stable. Okay? While if the compound is have unstable compound which have negative heat content are more stable. Okay? While the compound which have positive heat content, it is less stable compound. So stability of compound released by delta H of formation. Okay? If delta H of formation negative, this is means stable compound. And when the negative product or delta HF negative higher number is more stable. For example, I have HF and HCl. HF delta H of formation equal negative 271. HF and HCl. HF delta H of formation equal negative 271 and HCl delta H of formation equal negative 92 kilojoule per mole. So HF is have negative and large number which have negative sign, and HCl which have small number. So HF is more stable from HCl. Okay? And most of the reaction tend to produce and the direction of formation of the compound which lower value of delta H. So it's high stability. Okay? If we have, for example, SO3 and SO2, while the heat of formation of SO3 equal negative 395.7, while SO2 equal negative 296.8. So the heat of formation of SO3, it is less than the heat of formation of SO2. So SO3 is more stable. So the reaction will move in the formation of SO3. Okay? Finally, we'll talk about his law. Okay? The change of heat of main reaction, we can't measure it. So this depends on some type of factor. For example, product and reactant may be mixed with other substance. Some reaction take long time, for example, to occur. For example, rusting of iron. Iron to the iron to rust, it make long time, maybe 1 month or 2 or 3. It may be dangerous to measure the heat of reaction practically. Okay, so some reaction took care combined by formation of explosion. Okay, so مش هنحسبها يعني. It is hard to measure the heat of some reaction in standard conditions. Okay, so this factor that maybe we can't measure the change of heat directly. So scientists use Hess law to measure the heat of such reaction. What is meant of Hess law? Hess law, it measure with, or it is deal with chemical reaction as mathematical equation. Okay, and change of heat of chemical reaction is fixed. So Hess law of the reaction has the heat of the reaction has a constant value, which it doesn't change in a standard condition, even the reaction took place in one step, or more than steps. Okay? So the mathematical formula of Hess law, this means delta H1 equal H1. Delta H for the reaction equal H1 plus H2 plus H3 plus more than H. For example, we can measure change of heat combined to formation of carbon monoxide, C plus half O2 forming CO2. Okay? Because the oxidation process of carbon doesn't stop only in the formation of carbon monoxide gas, but it is continuous forming carbon dioxide gas. And we want to measure the change of heat combined to this chemical reaction. Okay? Focus with me, please. I have chemical equation number 1, C plus O2 and forming CO2. Delta H for this reaction equal negative 393.5. Negative 393.5 kilojoule per mole. And second equation, CO plus half O2 forming CO2. Delta H for this reaction equal negative 283 kilojoule per mole. And we want to measure change of heat combined to formation of carbon monoxide, C plus half O2 forming CO compound. Okay? We want to measure the change of heat combined to this chemical reaction. Okay. We use Hess law to measure change of heat combined to chemical reaction. Concentrate with me, please. We'll find 3 components found in this reaction or in this chemical equation: carbon, oxygen, and the carbon monoxide. Okay, carbon found in chemical equation number 1 and found in product and found in chemical equation number 1 in a product. So chemical equation number 1, find as it C plus O2 forming CO2, and delta H of this reaction equal negative 393.5. Okay, and the O2 found in two chemical equations, chemical equation number 1, chemical equation number 2, and CO number 3 found in chemical equation number 2 only. Chemical equation number 1 we didn't found CO. So CO found in chemical equation in product, and in chemical equation number 2 found in reactant. Okay, we have two steps, two solutions to this problem. We can subtract chemical equation number 2 from chemical equation number 1, or we can change the direction of chemical reaction. For example, we make the product replace reactant CO2 producing CO plus half O2, and delta H, change the sign of delta H. Delta H negative 200, delta H of this reaction negative 283 will make change the sign of delta H, so it's equal positive 283. Okay, thank you. This is what we need to sum two chemical equations. To sum two chemical equations, if we found the product, or we will cancel the substance found in product in chemical equation number 1 and reactant in chemical equation number 2. Okay, and reactant of chemical equation number 1 with the product of chemical equation number 2. If we have half O2 cancelled with 1, so we will find half O2. Okay, half O2, and we'll find half O2. So reactant we find C plus half O2 forming CO only, and this chemical equation we want to measure the delta H for it. Delta H equal H1 plus H2. H1 negative 393.5 plus 283. it's equal negative 110.5 كيلو جول بالمول. And we have finished this chapter 4. Okay, try to answer the question, okay, and my best wishes for you. Thank you.